Right now, tonight, there's a ball of ice and dust flying through our solar system that has swollen up so fast and so big that it now looks like it could swallow a planet. Just a few months ago, this object was too faint for almost any backyard telescope to catch. Today, it is bright enough to spot with a simple pair of binoculars, and it is still growing. This is the story of Comet 220P McNaught, and what has happened to it in the last 10 weeks is one of the strangest and most sudden comet events that skywatchers have caught in years. Let's start with the basics, because this is a real object with a real history, not a myth. Comet 220P McNaught was found on May 20th, 2004, by the Australian astronomer Robert McNaught, working at Siding Spring Observatory. McNaught is famous in comet circles. Over his career, he discovered dozens of comets. This one, simply called 220P, was just a faint smudge of light back then, sitting at around magnitude 17. For comparison, the faintest stars you can see with your naked eye on a clear night are usually around magnitude 6. A magnitude 17 object is thousands of times fainter than that. It takes a serious telescope and a long exposure to even notice something that dim. 220P McNaught belongs to a family of comets called Jupiter family comets. These are short-period comets whose orbits have been shaped and pulled by the gravity of Jupiter over long stretches of time. Instead of swinging out to the edge of the solar system like the famous long-period comets, Jupiter family comets stay relatively close in, looping around the Sun every few years. In the case of 220P, one full orbit takes about 5.5 years. Its closest point to the Sun, called perihelion, brings it to about 1.6 astronomical units out, just beyond the orbit of Mars. Its farthest point, aphelion, takes it out past Jupiter's general region before it swings back in again. So, this comet spends its whole life shuttling back and forth across the inner asteroid belt, diving close to the Sun and then retreating. For most of its history since discovery, 220P has behaved the way small comets usually behave. It brightens a little as it nears the Sun, it fades as it pulls away, and nothing dramatic happens. That changed this year. In late May of 2026, comet watchers using data from the Zwicky Transient Facility, a robotic sky survey that scans the heavens every single night, noticed something odd. An astronomer named Mike Kelly flagged it first. The comet had suddenly jumped in brightness by about 7 magnitudes. To put that in plain terms, 7 magnitudes works out to roughly a 600-fold increase in brightness in a very short window of time, somewhere between 13 and 14 hours. Other observers who tracked it in the days that followed reported it climbing even further, all the way up to about magnitude 8.2. And that would mean the comet brightened by something close to 8,000 times compared to where it had been sitting just days earlier. Imagine a candle in a dark room suddenly turning into a spotlight overnight. That is roughly the scale of what happened here. This kind of event is called a cometary outburst, and while it sounds dramatic, it is a known and studied phenomenon. It happens when a comet's nucleus, the solid chunk of ice, rock, and frozen gas at its core, develops a crack or a weak spot in its crust. As the comet approaches the Sun, sunlight heats the surface. Buried underneath that surface are pockets of frozen material, things like carbon dioxide ice or carbon monoxide ice, which turn to gas at much lower temperatures than water ice does. When one of these pockets gets exposed, either through thermal cracking, a small landslide on the nucleus, or even a tiny fragment breaking off, the trapped gas rushes outward all at once, carrying a cloud of dust with it. That sudden venting is what we see from Earth as a burst of brightness, because now sunlight has a much larger cloud of fine dust and gas to reflect off, instead of just the small solid nucleus. Right around the time of this first outburst, professional astronomers pointed the TRAPPIST-North telescope in Morocco at the comet to get a closer look at its chemistry. What they found was interesting. The comet's coma, the cloud of gas and dust surrounding the nucleus, was unusually rich in a molecule called diatomic carbon, written as C2, compared to another common cometary gas called cyanogen, or CN. Diatomic carbon is part of why comet comas often glow with a greenish tint, since C2 emits light strongly in that part of the color spectrum when it is energized by sunlight. The astronomers also noticed the comet had a narrow, intense dust tail that stood out clearly in their images, and they raised the possibility that the outburst might have been connected to the nucleus actually breaking apart a little, a process scientists call a fragmentation event. When a comet nucleus loses a piece of itself, whether a small chunk or just a chunk of crust, it exposes fresh ice that has never been heated by the sun before, and that fresh ice can vaporize violently. The comet reached its perihelion, its closest approach to the sun, on June 14, 2026, at that distance of about 1.6 astronomical units. That timing matters because comets are most likely to have outbursts when they are nearest to the sun and receiving the most heat. As it turned out, the comet had already started to calm down before it even reached that closest point. By early June, observers noted that its dust production rate had already dropped noticeably between one night and the next, and over the following weeks, it faded steadily. By June 8th, it had dimmed to around magnitude 11, still far brighter than its original state, but clearly settling down from its explosive high point. Astrophotographers captured it during this fading phase, showing a coma that had stretched into a teardrop shape with an elongated, less concentrated center, a sign that the burst of material was slowly spreading out and thinning into space. By early August, it had faded further down to around magnitude 13. Then, on August 5th, it happened again. Without warning, the comet brightened a second time, jumping back up to around magnitude 7, arguably even brighter than the peak of its first outburst just 2 months earlier. This second flare-up caught the amateur astronomy community by surprise all over again. A comet having one major unexpected outburst in a single apparition is already somewhat unusual. Having two significant outbursts within the same close pass by the sun, separated by only about 2 months, is rarer still. And it has pushed 220P McNaught firmly onto the radar of comet watchers around the world, who are now tracking it night after night to see what it does next. What makes an object like this worth paying attention to isn't really its size in the traditional sense. The solid nucleus of 220P is tiny. Based on studies of similar Jupiter family comets, nuclei like this one are typically only 1 to 2 kilometers across, sometimes even smaller. That is barely bigger than a small town. You could drive across it in a few minutes if it somehow had roads. But the coma, the cloud that forms around that nucleus once it starts venting gas and dust, is a completely different story. Because there is essentially no air resistance in space to hold the cloud together, and because the pressure released during an outburst pushes material outward in all directions, comas can balloon out to sizes that dwarf entire planets, even though the object producing that cloud remains small and solid at its core. This isn't a new or unusual idea in comet science, and there's a famous historical example that shows just how extreme this can get. In October 2007, a comet called 17P/Holmes underwent one of the most dramatic outbursts ever recorded. It brightened by roughly 1,000,000 times in a matter of days, jumping from a faint magnitude 17 all the way to about magnitude 2.8, bright enough to be an easy naked-eye object, even from a city. In the weeks that followed, the cloud of gas and dust it released expanded so much that, at its largest, the coma of Comet Holmes became physically larger in diameter than the sun itself. Even though the solid nucleus producing all that material was estimated to be only a few kilometers wide, it remains one of the most talked-about cometary events in modern astronomy, and it is the clearest proof that a small, unremarkable chunk of ice can, for a brief window of time, generate a cloud of material that is genuinely planet-sized or larger. 220P McNaught's outbursts this year are being watched with that kind of history in mind. While detailed measurements of exactly how large its coma has grown during this second August flare-up are still being gathered and confirmed by observers as new images come in, the pattern already fits the profile of a comet undergoing a genuine burst of activity, capable of producing a coma many times larger than the solid body buried inside it. Earlier in its apparition, during the first outburst back in June, observers already measured a coma stretching several arcminutes across in the sky, along with a faint ion tail reported to extend more than 2 full degrees in length, which is roughly 4 times the apparent width of the full moon as seen from Earth. An ion tail that long, made of charged gas particles streaming away from the comet and being pushed by the solar wind, is itself a sign of just how much material was being released. So, where's this comet right now? And can you actually go outside and see it yourself? As of this week, 220P McNaught sits in the constellation Cetus, the Whale, a constellation best seen in the pre-dawn sky. If you are in the northern hemisphere, the timing is a little tricky at the moment, because a half-lit moon is rising around the same time as the comet, and its glow can wash out a faint, diffuse object like a comet's coma, which does not have the sharp, pinpoint brightness of a star. Observers in the southern hemisphere currently have a somewhat better shot, with roughly a 30-minute window in a moonless sky before dawn light takes over. Although the comet stays fairly low near the eastern horizon during that time, so a clear view down to the horizon helps. For anyone hoping to catch it, the advice from experienced comet watchers is simple. Get away from city lights. Give your eyes at least 15 to 20 minutes to adjust to the dark, and use binoculars if you have them, since a diffuse glowing patch is often easier to pick out with binoculars than with the naked eye alone. A small telescope will give an even better look, potentially showing some structure in the coma or a hint of the tail. Because outbursts like this are inherently unpredictable, and comets can fade just as fast as they flare up, the general rule among skywatchers is to try to see it as soon as you reasonably can, rather than waiting, since there is no guarantee it will still be this bright next week or even in a few days. It's worth stepping back and asking why scientists care so much about small, faint comets like this one in the first place. Beyond the excitement of a surprise outburst, comets are often described as time capsules from the early solar system, when the sun and planets were forming more than 4.5 billion years ago. The outer regions of the swirling disk of gas and dust around the young sun were cold enough for ices to form and survive. Comets are believed to be leftover building blocks from that era, chunks of primitive material that never got incorporated into a planet and have been drifting, mostly frozen and unchanged, ever since. Every time a comet like 220P swings in close to the sun and its ices start to vaporize, it releases gas and dust that essentially has not been touched since the solar system was born. Studying the chemistry of that material, like the enriched diatomic carbon signal picked up by astronomers observing this comet in June, gives scientists real data about what the raw ingredients of our solar system actually look like, without needing to send a spacecraft all the way out there. Jupiter family comets in particular are important because they're more frequent close passes by the sun, compared to long-period comets that might not return for thousands of years, means scientists get repeated chances to study the same object and watch how it changes and degrades over time. Some Jupiter family comets eventually run out of accessible ice near their surface after enough close passes and effectively go dormant, looking more like ordinary rocky asteroids. Others, for reasons not always fully understood, keep surprising observers with dramatic activity even after many orbits. Whether 220P McNaught will settle down after this pair of outbursts, or whether it has more surprises left before it heads back out toward the far end of its orbit, is something only continued observation will answer. This comet is not traveling alone through the summer sky. Several other periodic comets have been active in 2026 as well, giving comet watchers a busier than usual season. Comet 10P/Tempel 2, another periodic object with an orbital period of about 5.5 years, passed its own perihelion on August 2nd at a distance of about 1.4 astronomical units from the Sun, putting it in roughly the same neighborhood as 220P around the same time. Comet 88P/Howell, which also completes an orbit in roughly 5.5 years, reached perihelion back in March at a similar distance. Let's talk a little more about that green glow, because it's one of the more visually striking parts of what people are photographing right now. When you look at recent images taken by astrophotographers of 220P McNaught, especially the shots taken close to the time of the outbursts, the coma often shows a distinct greenish tint. That color is not an artifact of the camera or the processing. It comes directly from the diatomic carbon, the C2 molecule mentioned earlier, which astronomers detected in unusually high amounts in this comet's coma. When sunlight hits C2 molecules floating in the near vacuum of space, they get excited and emit light at very specific wavelengths, and those wavelengths happen to fall right in the green part of the visible spectrum. This is the same basic reason a lot of bright comets going back through history have been described by observers as having a greenish head, even though the tail often looks more white or bluish, since the tail is dominated by different gases and by sunlight simply reflecting off dust grains rather than glowing on its own. So, when astrophotographers post their images of 220p right now, showing that vivid green core, they are essentially capturing a chemical signature of the comet's composition, not just a pretty color. It's also natural to wonder, given how much this comet has grown, whether there is any reason for concern about it passing near Earth. The short answer is no. Comet 220p McNaught stays out near the orbit of Mars during this part of its journey, more than 1.5 astronomical units away from the Sun at its closest, which puts it tens of millions of kilometers from Earth, even at the nearest point in its current orbit. Its path does not bring it anywhere close to a collision course with our planet. Astronomers track periodic comets like this one precisely because their orbits, once well established through repeated observation, become quite predictable in terms of where the comet will be years or even decades into the future, even if exactly when it will have an outburst remains impossible to forecast. The interesting thing happening here is entirely about brightness and visibility from a great distance, not about proximity or any kind of physical risk. It's also worth remembering that Robert McNaught, the man this comet is named after, has one of the most prolific careers in the history of comet discovery. Over the course of his work, primarily using wide-field survey telescopes designed to sweep large areas of sky looking for moving objects, he was credited with discovering dozens of comets, of which this one, found back in 2004, was actually the very first to bear his name in the official catalog. Comets are traditionally named after their discoverers, which is why you'll often see the same surname attached to several different numbered comets. A single dedicated observer using the right equipment can rack up multiple discoveries over a career. It's a nice bit of context for an object that, more than 20 years after it was first spotted as a barely visible smudge, is now putting on the most dramatic display of its observed history. It's also worth putting this event in perspective against comet outbursts that have made headlines in past years, since it helps explain why this particular case has generated so much buzz among observers. Beyond the extreme example of Comet Holmes in 2007, smaller outbursts happen more regularly than most people realize. Comet 29P/Schwarzmann-Watchman, for example, is famous among comet watchers for having frequent outbursts, typically brightening somewhere between 1 and 4 magnitudes at a time, far more modest than what 220p has just done twice in a row. What sets 220p McNaught apart this year is both the sheer scale of its first jump, roughly 8,000 times brighter within about half a day, and the fact that it repeated a major flare a second time within the same apparition, an occurrence that is far less common and one that astronomers don't fully understand the mechanics of yet. Some comet scientists suspect that once a nucleus has one major crack or fracture event, the exposed area created by that first outburst can remain unstable and prone to further collapses or venting as the comet continues to be heated by the sun, which could help explain repeat outbursts like this. Others point to the possibility of the nucleus actually being made up of more than one loosely bound piece, something astronomers have documented in a handful of other comets, where each piece can vent independently at different times. At this stage, with the second outburst only days old, researchers are still gathering images and spectra to try to figure out exactly what triggered this particular repeat performance. And it may be some time before a clear answer emerges, if one emerges at all. Comet behavior, even after decades of study, remains genuinely difficult to predict. There's something worth sitting with here beyond just the numbers and the magnitudes. A piece of ice and rock roughly the size of a small hill, drifting largely unnoticed for most of its multi-year journey around the sun, just twice in the space of 2 months released enough material to become briefly one of the more talked-about objects in the amateur astronomy world. It went from being an object so faint that only a robotic survey camera scanning the entire sky every night would even register it, to something a person standing in a dark backyard with a pair of $10 binoculars can actually pick out against the stars. That kind of transformation, driven purely by heat, ice, and the physics of a fracturing surface millions of kilometers away, is part of why comets have captured human curiosity for as long as people have been looking up. There is no need to reach for anything beyond the real physics here. The actual story is dramatic enough on its own. A small, cold, mostly forgotten traveler from the frozen depths of our solar system had two outbursts of activity within the same close pass by the sun, throwing off gas and dust that spread out into a glowing cloud large enough to be tracked by observers on every continent. For now, the best thing anyone curious about this event can do is simply go check it out for themselves if the skies allow. Comet 220P McNaught is sitting low in the pre-dawn sky in the constellation Cetus, reachable with binoculars under a reasonably dark sky, though moonlight and its low position near the horizon are making it a bit of a challenge this week, depending on where you're watching from. Whether this second outburst is the last surprise this comet has for us this year, or whether there's a third act still to come as it continues its slow retreat away from the sun and back out toward the far reaches of its orbit, nobody can say for certain yet. That unpredictability is exactly what has watchers checking their feeds and their telescopes again tonight, and probably again tomorrow night too, just in case this quiet little traveler from the edge of the asteroid belt decides to light up one more time before it fades back into the dark for another 5.5 years. If you do manage to spot it, or even just find good photos of it online over the coming days, it's worth taking a moment to think about the scale of what you're actually looking at. A nucleus smaller than most small towns, invisible to the naked eye on its own, even with a strong telescope, has thrown off enough gas and dust to build a cloud that from Earth looks like a soft, glowing smudge among the stars, bright enough to notice with basic binoculars from a dark backyard. That cloud is made of material that has been locked in deep freeze since before the Earth itself had fully formed, only now getting its first real exposure to sunlight in over 4 billion years. Every time a comet like this flares up, it's giving us a small, temporary window into the earliest chemistry of our solar system, released for a few weeks before it thins out and disappears back into the emptiness of space. Comet science moves fast when something like this happens. Observers around the world, from professional observatories running dedicated comet monitoring programs down to amateur astronomers with backyard telescopes and cameras, are all pointing their equipment at the same patch of sky right now, comparing notes and posting updated brightness estimates almost daily. That kind of collective, fast-moving observation is exactly how outbursts like the 220P McNaught has produced this year get properly documented, tracked, and eventually understood. So, if this is the kind of story that catches your attention, it's worth checking back in over the coming days and weeks, because a comet this active, this early in what should have been a quiet apparition, has a real chance of doing something unexpected again before it finally settles down and heads back out toward the far, cold edge of its long, looping orbit around the sun.